Guys, now we are going to solve this nice radical problem. So here 5 to the power x minus 10 to the power x over square root of 50 to the power x minus 100 to the power x is equal to 1. You just take this denominator to the right hand side. So we have 5 to the power x minus 10 to the power x is equal to square root of 1 times this is same term. So 50 to the power x minus 100 to the power x. Okay, to remove this square root, we have to squaring on both sides. Okay, so we have to squaring on both sides. We have 5 to the power x minus 10 to the power x. The whole squared is equal to square root of 50 to the power x minus 100 to the power x, the whole square. So this square and the square root get cancelled. So we have 5 to the power x minus 10 to the power x, the whole squared is equal to 50 to the power x minus 100 to the power x. Okay, now we are going to make use of the substitution. A is equal to 5 to the power x and b is equal to 10 to the power x. So that is our problem is here. 5 to the power x minus 10 to the power x, the whole squared is equal to 50 to the power x minus 100 to the power x. 50 to the power x minus 100 to the power x. Our substitution is a is equal to 5 to the power x and b is equal to 10 to the power x. So we are going to use this. So a minus b, the whole squared. A is 5 to the power x and b is 10 to the power x. The whole squared is equal to 50 can be written as 5 times 10 whole to the power x minus 100 can be written as 10 times 10 whole to the power x. Or you have this is 5 to the power x times 10 to the power x minus 10 to the power x times 10 to the power x. Using the formula ab whole to the power n can be written as a power n times b power n. And again we have to use this substitution here. A times b minus b times b. So here left hand side a minus b the whole square. So we have to take the these two terms to the left hand side. So we have a minus b the whole squared minus ab plus b times b is b squared. Here you have minus, so this side it comes plus, is equal to 0. So from this we have to take 1 minus b outside. So a minus b the whole squared minus b times a. Here minus b is taken outside. So a minus b is equal to 0. So from this you can take 1 a minus b outside. So a minus b times, after taking 1 a minus b, another a minus b is left out. And here this is taken outside and minus b is there, is equal to 0. So from this we have a minus b times a minus 2b is equal to 0. So from this product of two terms is equal to 0. At least one should be equal to 0. So a minus b is equal to 0 and a minus 2b is equal to 0. From this we have a is equal to b and here we have a is equal to 2b. What is a? A is equal to 5 to the power x is equal to b is 10 to the power x, and here we have 5 to the power x is equal to 2 times 10 to the power x. So we are going to simplify this. Okay, so 5 to the power x is equal to 10 to the power x and 5 to the power x is equal to 2 times 10 to the power x. Yes, 2 times 10 to the power x. Now we are going to simplify this. Take this 10 to the power x to the left hand side denominator. So 5 to the power x over 10 to the power x is equal to 1, or you have 5 by 10 whole to the power x is equal to 1. This is 2 times. Here, this term can be written as 1 by 2 whole to the power x is equal to 1, or you have 1 by 2 whole to the power x is equal to 1 by 2 to the power 0, that is equal to 1. So compare base is same, we can equate the powers. So we get x is equal to 0. One value for x is 0. And from this we have 5 to the power x. Take this 10 to the power x to the denominator is equal to 2, or you have 5 by 10 whole to the power x is equal to 2, or here you have 1 over 2. 1 over 2 whole to the power x is equal to 2. Okay, 1 over 2 whole to the power x is equal to 2, or you have a 2 by 1, you can write it, or 1 by 2 whole to the power x is equal to 1 by 2 whole to the power minus 1. When you're taking reciprocal for this, you have to put this to minus 1. So here base is same. So here x is equal to minus 1. So x is equal to minus 1 is 1. Solution we got it, but we have to check in the given problem. So when if our problem is 5 to the power x minus 10 to the power x over square root of 50 to the power x minus 100 to the power x is equal to 1. When x is equal to 0, our problem becomes 5 to the power 0 minus 10 to the power 0 divided by square root of 50 to the power 0 minus 100 to the power 0 is equal to 1. This implies, here you have 0. 5 to the power 0 is 1. 1 minus 1 divided by square root of 1 minus 1, which is 0 by 0. So indeterminate form you can get it. So x is equal to 0 is not a solution. Okay. So we have to check for x is equal to minus 1. When x is equal to minus 1. So this is not a solution for the given problem. So when you're substituting x is equal to minus 1 here, 5 to the power minus 1 minus 10 to the power minus 1 over square root of 50 to the power minus 1 minus 100 to the power minus 1 is equal to 1. So from this you have this term can be written as this implies 1 over 5 minus 1 over 10 divided by square root of 1 over 50 minus 1 over 100 is equal to 1. Okay, so we have to simplify this. So here this term is, we have to check this. So we get this is 1 over 5 minus 1 over 10 divided by square root of 1 over 50 minus 1 over 100. 1 over 50 minus 1 over 100 is equal to 1. That is, from this you have to, that is when you multiplying this by 2, you get the basis 10, and in the same way you multiply this by 2, you get basis 10. So from this you have 2 minus 1 over 10 over square root of here 2 minus 1 over 100 is equal to 1, or this term is 1 over 10 divided by square root of 1 over 100 is equal to 1. From this 1 over 10 divided by square root of 1 over 100 is 1 over 10 is equal to 1. So these two terms get cancelled. 1 is equal to 1. So we can say that x is equal to minus 1 is the only solution for this given problem. Thanks for watching. Subscribe our channel for more videos.